Hello everyone. I hope you're doing well and you're fit and fine. Today we're gonna solve this problem which could come in the code for the recent contest, last contest only yesterday itself. And there's a D1 problem. It's a easy version. It's a easy problem, but it's a actually you can say a non-intuitive type of problem that it's very difficult to think about that bhaiya, how to think it and like how to learn from the problems that if a new problem comes to you, you can solve that. And with that, let's get started with the video. If you are new to the channel, make sure you hit the subscribe button and like the video because we make content around DSA, tech, AI, and also we recently launched an OOPS course which covers everything from interview ready, practice questions. It's live. We're gonna post, and the first lecture is being released. Do check it out. The link is in the description. Cool. Let's try to read this problem. The problem is very short. It's not a very usual for code forces question, right? Code forces big question. Yeah, बहुत बड़ा question, right? But okay, this is an easy version. Okay, difference between the version is L is equals to 0. Very important. And R is less than 2 into 10 power 5. Okay, fine. Okay, and then you're given with n equals to n, I will be creating two arrays a and b, both consisting of n integers. Initially, both are equal to l plus 1 till r. So let's say you have l, always l equals to 0 in this problem, r equals to let's say 3. So your array will look like 0, 1, 2, and 3. I hope you understood that, right? You have to reorder the array arbitrarily to maximize this value. This is not the conditional probability. This is the OR operation. We did, the bitwise OR operation. You also need to construct a possible way to reorder that. This makes this problem a D problem. This thing only value if you want to tell. That's a you can say B level problem. It's not very difficult to judge that, but to construct that, that's an interesting problem. Okay. First thing that what comes to your mind, obviously, you will see the examples and you observe a pattern. Say in code forces question, right? You have to make some observations. Observation is the key. The greedy ideas, these kind of problems which are not based on some dynamic programming things, not based on some graph problems, right? You have to be very vigilant about your observation. तो हमने क्या ऑब्जर्व किया भैया? हमने देखा कि 0 to 3 जब दिया था तो आंसर आया था 3, 2, 1, 0, that we can order this way, then what we'll get the maximum. How? Let's see. 0, 1, 2, 3. If you do the OR, what will be the answer? 3. This also be 3. This also be 3. This also be 3. And answer will be 12. You will be like, okay. And then भैया हमने ना 0 to 15 वाला भी देखा था. This is also giving something answer as 240, which is surprisingly 16 into 15. Hmm. Okay, and also भैया 0 to 9 में भी आंसर 90 आया था, which is nothing but 9 into 10. From here you should get a hint. Okay, there is a pattern. At least the value. We got some hint. Okay, this makes sense. This makes sense. Hmm. Okay, that does particularly make sense. That okay, we can find actually the value because we need to tell the value as well. We have to find the array construction as well. Okay. Okay. So what do you want to maximize? We want to maximize AI or BI. Okay. Summation we have to maximize. And we know that everything is from 0 to R. Everything is from 0 to R. A, B and BB. Okay. That's fine. See, whenever you get these kind of problems, right? When you want to maximize that, try to think like that. Okay, what is the maximum value? What is the maximum value of AI or BI? What is the maximum value? Tell me. Tell me what is the maximum value if you can get. You will be like, भैया, it's pretty simple ना. AI और BI का और है. So means if BI are it's some complement of AI or some bits which are not set in BI are set in AI. Sort of, you can say that AI BI is less than equals to AI plus BI the summation. Did you get that? Why I'm saying that? Let's say basically there are some bits which are set in BI which are not set in AI. So we'll get from that AI. And then let's say which are some in AI which are not in BI. Let's say you can say that 1, 0, 1, 0 is 1, 1. And this you can say some bits are set here 0, 0, 0, 0, right? So always the maximum will be you can sum up both the values individually. There is no bitwise or required because they are sort of not exactly complement. The complement is the maximum value you can get. Like all bits will be set to 1. but it's not need to require complement, right? You can add them as well, because in this case, this bit will be 0, irrespective of that. So you will be like, okay, and what is this value? Array, this is the fix, right? Summation of AI plus summation of BI, which is what? Tell me, which is n into n plus 1 by 2 plus n into n plus 1 by 2, and which is equals to what? N into n plus 1, which is nothing but r into r plus 1. So this is, you should understood this thing, okay? Yes, I understood it, bhaiya, that this is at least the sum we got it. And this is the maximum possible we can get it. Can we get this possible thing? That's our thing. This is the maximum possible. But is this the final answer? Yes. From trying the observation, if you check, bhaiya, it is like 3 into 4. It is like 16 into 15. It's like 10 into 9. Yes, it is something like that. Can you try to prove it? Okay, something is happening in maximum terms. So can we write always AI or BI as summation of AI plus BI? And what we will require? What we will require? We will require somehow in the greedily idea that we have to, if we fix some AI, obviously let's fix AI, that we have to find BI, right? So let's fix BI, that okay, they are in this certain order, which is like 0, 1, 2, 3, 4, 5, 6. Let's see the example of firstly 3, and then we'll try to see in the later examples. 0, 1, 2, 3. Okay. Then the first greedy idea that comes to my mind, oh, I want to maximize this bitwise, or you will be like, भैया very simple ना, ऐसा कर दो यार. What is the problem? Oh, we are getting also 12 in the 15 also we are getting 12, but it won't be always the case. If you can see the example of 9, you won't get it. Means basically won't get in the cases of not powers of 2. If r is not a power of 2 minus, you can getting it. Like if you won't get in these cases. In these cases, you won't get the answer. You can check it out. Or also in 9 also, you cannot get the answer. You cannot get this. You can try it. You can, it's not always an intuitive idea only, right? But this will fail. That is not always guarantee that this will always cover the bits, because it will cover some overlapping bits. If you can see, if you do that, let's try to do that. The problem is, okay, this is fine. This is fine because there's no overlapping bits. That's good. Here also no overlapping bits, but here there is an overlapping bit. We don't want to do that. We don't want to do that. Why? We can somehow, can we permute in such a way that there's no overlapping bits. ये हमारा final main goal है. या हाँ, कुछ तो समझ में आया, क्योंकि that will increase it to AI plus BI, right? Because we can achieve this, because all are the ranges from 0 to n only. तो ऐसा कुछ तो कर सकते हैं भैया. ठीक है भैया, यहाँ तक हमको समझ में आया. फाइन, फाइन, फाइन. लेट्स ट्राई टू डीप डाउन एंड ट्राई टू थिंक. ओके, लेट्स ट्राई टू ड्रॉ इट. लेट्स ट्राई टू ड्रॉ इट. ओके, 0 to 5. So 0, 0, 0. Here, 0, 0, 1, 0, 1, 0, and 0, 1, 1, 1, 0, 0, and 1, 0, 1. Okay, भैया, 0 to 5. Fine, no problem. Now, let's start from the back. Okay, that what are the compatibles? What I want to do, I want to pair a particular number such that it should not have a common bit with it, right? I want that AI and BI should be 0 for maximum bitwise or, right? That will be helpful. Now, what are the possible candidates? The possible candidates are like, this is not a possible candidate, 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 because everything is overlapping. No, this is a possible candidate. This is a possible candidate, and this is also a possible candidate. But what do you want to pick? What do you want to pick? You can pick this. You want to pick this. Why? We'll see that. We'll see in the later things that okay, when we pick the largest one with largest thing, do it, because this can be paired with everyone, right? Above ones can be paired with the later ones easily, but this might not be paired with everyone easily. Above ones can be paired up with everyone easily. That's a greedy idea what we thought about. Let's try to pair them. Okay, 5 is paired with, okay, and if they are paired, we won't check it on that. Okay, now we come to that. What we do again, complement of that, something like that, right? This is a compatible thing. So what do we do? 4 with complement with 3. Okay, when we come to 3, oh, they're already marked, no need to do that. Come to here. Okay, so we come to here, so we mark. So what's, oh, and down, what is left? This is only left and this is only left, so they will be marked. So 1 with 0. This is our answer. If we can check that, always get the sum. How? You can check that here. 5 and or and with 2 is what? It will be like 7. Okay. 4 with 3 or is again 7. And 1 with or with 2 0 is 1. And you can see that it is like 14, 15. And it's like 4 into 5. Second, 4 and 4 with 3. Yes, it's or is 7. And okay. And obviously, we have to do it opposite also, right? 2 pair with 5, 5 pair with 2. So it will be like this double, right? So how many elements we have? We have like n into n plus 1. So 5 into 6, which is equals to 30. And here also 15 into 2 equals to 30. Why 2 bhaiya? By 2 also 5 will also be counted, 3 and 4 also be counted, and 0 and 1 will be counted. All will be double, 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 right? So it will be double because we have to create a mapping, right? It's not on the 3 element, it will be 6 elements, right? So you'll be like, okay, this makes sense that we have to somehow find the largest value for a particular AI. I have to find a something BI that will correspond. They have no overlapping bits. That's my idea, and which is the largest thing. Okay, okay. Let's fix an X. Okay, we have a X. Okay, then you will be like, okay, now here is a non-intuitive thing. I will tell you. Try to think about it. Try to learn from this. Okay, for next time you can do this. Okay, so I will tell you a property that let's say there's X given that, right? Now, what you want to do, you want to check that, okay, what I will do is there's a property that 2 power k minus 1 minus x, these two will be always, if you do a and, will be 0. How? Let's see. Try to, it's intuitive, right? Some things, this property is not intuitive, but when you try to think about it, it's intuitive. See, what we are essentially doing, and x is less than 2 power k. So, what we are actually doing, we are doing the highest power of k. Like, let's say we pick the highest power of x, whatever is set. Let's say for 5, the highest power is this bit, right? 101, and this is the highest bit. So what we had picked, let's say we pick k is equals to 102, 3 we pick, right? We pick 3. Then what we are doing, we're doing a minus 7. And then what we are doing, try to imagine this 7 means all the bits are set to in the x. Okay, now what we are doing, we are removing these bits where x is present. We're removing the bits where x is present. So what will remain? If you take the and, it will be always 0, right? So what we are trying to emphasize here is that we will actually trying to set all the bits in X. That's our greedy idea. Okay. Let's say 9 is there. So we'll set all the bits. Let's say X is 9. So what we will do, we'll set all the bits 15, and we want to remove the bits. So what if I remove difference took a 9, what will be removed? This will be removed. What will be removed? This will be removed. What will remain? This will remain. And that is our BI that we desire. That is the idea. That is the idea, right? What you want to do? Pick the largest possible bit set in the array. We do a 2 power k minus 1 for that. And let's suppose, yeah, if it is itself a power of 2, then what will do that? Let's say it is 15 itself. So what? How will do? No problem. It will be mapped with 0. Let's see. So it is represented by this. And then what we gonna do? We're gonna do k. We found out to be 4. So we do a 2 power k minus 1, which is 15 itself, and you subtract 15 and it becomes 0. And you can pick the 0 as well, no problem. 15, 1, 1, 1, 1, 0, and all will be 0 itself. Right. So our idea was very simple, that what we want to do, because we want to map up with the largest possible, which is non-overlapping. That's our idea. So what we did, we make its 2 power k. We set all the bits in our current text, and then we removed x itself from that minus x itself, and then we try to do that. And if you try to observe that, it's a double mapping, right? So for this element, let's say we found out, so what we are essentially making is, this is a double mapping for a particular x. We map it to 2 power k minus 1 minus x, and for 2 power k minus 1 minus x, map it to x. This is a double mapping because both will give us the same or, right? If you do this or this, you do this or, it's the same, right? That we want. There's non-overlapping, the largest possible k. We want it, right? And this is the greedy idea. We have to find this k, and how to find this k? K is nothing but number of bits in X. That's what I explained, right? See, this property. uh, and is always hold when x is less than 2 power k. You can try to check it out. That it will always hold. But I already told you that you don't want for everything. We want that for maximum k because we are going on the upward trend. Upward trend. Why we are going in upward trend? Because this per element can be mapped with lower elements easily. Not always, but yes, it's easily. Multiple possibilities are there. But as you go down, the possibility reduces. So we want to go up. That's why larger element should be merged with smaller elements. That's a greedy idea what we are trying to follow. And that's why we have to do this. If I have to find k, in k, we observe that this is number of bits in the k because we want to maximize that. And that's it. This is done. Let me just show you with the help of quick example for 0 to 9 as well. So what we have to do with 0 to 9, let's try to set all the bits. 000, 0001 0. You will try to observe and you will understand, oh, this is the reason why. Yeah, this sometimes I know that thoda sa non-intuitive hai, but some things you have to learn as well, right? Some properties you learn. Oh, this property you learn today that if you do a and with x and 2 power k minus 1 minus x, you will always get 0. Might be useful in some other contest, right? So try to learn always. That's the thing. Now, what do you do? This is the idea. Now, what you want to do? We'll go from here. We'll find its pattern. So, what is the k value here? K value is 4. You will be right. Okay. K value is 4. So, what are you going to do? I will find the 2 power k minus 1 means 15 minus 1 or means sorry 16 minus 1 minus the x itself which is 9 which remains 6, right? And we'll map it to 6. And you can see that there's no overlapping, right? And we want that this is mapped with this. Fine. Then what we're gonna do? We're gonna go with this. Now what we're gonna do? Same thing. 15 minus 8 minus oh, sorry 15 minus 8. Yes, which is equals to 7. And we're gonna map this to this. You can see that, right? Again, they're mapped. Now, if they're already mapped, no need to map it again. Just skip that element. We already mapped them, right? Bidirectional map here. Now, if we go to this element, what we are there? Only 3 bits are there, which means 7. 7 minus 5, 2. So this will be mapped with this element. Okay. Similarly, if you go to this, what will be mapped? It will be mapped with this element. And if you go to above, see, there's not that this cannot be mapped with this. This can be mapped, right? There's no overlapping bit, but we want to we want to maximize this answer and we have to cover everything possible. And in this way, we're covering every bit to be one, right? We want to cover every bit. That's what our maximum will reach. That's our greedy idea that we want to cover every bit towards the end. So I hope you understood the entire intuition. And if you understood it and if you like the video, make sure hit to the subscribe to channel. And yeah, we are covering the Oops playlist for you guys. So yeah, do check it out and do let me know the feedback on that. Then see you in the next video. Bye bye.